Awesome. Thanks for that quick introduction. We're going to have a really fast-paced hour here, but we do want your questions, so really do just type them in as we go, and we'll be sure to answer them. But this is an exciting webinar because over 150 tourism boards use our data, many through other vendors that you actually might work with. So maybe you don't work with us directly, but you work with a vendor partner that does. And we feel, honestly, we have a responsibility to be as transparent as possible on our data, where it comes from, what we do to ensure it's accurate, its representativeness, and honestly, that it's used to answer the correct questions. So today, we're not showcasing any products. We're not trying to sell anything. This is really just a transparent learning experience. I'm going to pass it to Evelina, who's going to do the first session of this, and then I'll walk through the next section of it. But Evelina and I work pretty much hand in hand, delivering data to many of our partners, vendors, and destinations alike. So if you haven't met Evelina before, you've definitely worked with her if you've worked with our data in some capacity. So with that, I'll hand it over to you, Evelina.
Thanks, Evan. As you can probably hear from my tone, I'm very excited to be here today. Evan and I have done multiple webinars that look at how destinations can use mobile location data to break down their visitor segments, understand what they're doing, how long they're staying. In past CTRA presentations, we've shown how mobile location data can answer the big three questions: where, what, and who. We looked at the top 3 national parks for summer travel: Yosemite, Yellowstone, and Glacier. And we compared who was coming in 2019 and how that share has changed in 2020. Recognizing the importance of shifting to the local market, we looked at how locals were traveling. Where were they going? What were they doing? And when hotels were just beginning to operate again during the pandemic, we looked at who was staying at the hotels and Airbnb and how that demographics have changed from 2019 to 2020. Well, the reason why I'm so excited for today's presentation is because we're going to take it one step further. We're going to get into the nitty-gritty of mobile location data, all the filtering, cleaning, formatting that needs to be done, so you can make these presentations and be able to analyze the data and show your findings. Why are we doing this? Well, because we want you to become the expert. Okay? Many of you who have been on phone calls with me have heard me say, I want you to be as educated and as much of an expert on mobile location data as I am. For every researcher, data collection methodology is core to our data analysis and findings. From our time in college when we first presented our first field research paper to when we're in the boardroom in front of C-level executives and government officials, establishing the value around our findings includes establishing confidence in our data collection methods. Now, in 2017, when mobile location data was beginning to show its prominence in the retail and real estate sector, this survey showed that the #1 concern of C-level executives is ensuring the quality of the data, followed by being able to extract it in a usable way. I've been in this industry for the last 5 years. I've been in the forefront of bringing this data to the retail and real estate industry. And I think the tourism industry is at a similar position as retail was in 2017. In terms of a data maturity model, we're seeing that your industry is adopting mobile location data as a core to understanding crucial tourism questions. And so that's what we're going to do today. As you're answering those questions, these questions that you see up here on the slide are just as important. How precise is the data? Is it trustworthy? What about data sources? What should I know about them? And how is privacy addressed? And once you get all of that baseline information through, it's then using the data. And so we're going to dive into how you can use the data, how it can look, and what questions you can answer with it. We're going to talk specifically to some of the things that Uber Media does. But we're also going to talk and give some best practices as what we believe in general, the mobile location data space should also be doing. So keep that in mind with not only working with us and asking these questions, but also with any other mobile data vendors. These are core questions that need to be asked to ensure that you're getting the best quality data. So take this slide here. One of the first questions that needs to be answered by every mobile location vendor: how much data do you have? At Uber Media, while our dive in tourism is recent, we take pride that we're the seasoned experts in the space. We have 10 years of experience, and that's resulted in us being one of the largest aggregators of this type of data intelligence. And being the largest aggregator is not a coincidence. That's from what we've learned about the data and how we believe mobile location data should be looked at. So these metrics that you see here, this is what we've decided is clean and accurate enough for our clients to use. But did you know that we've built an infrastructure that scrubs through over 5 million data points of new data each second? And that we're taking in millions of data internationally per day. But most importantly, did you know that we throw away 75% of the data that we ingest? It's thrown in the trash, 75% of that. But that's what comes with experience. We've seen it all. We know the small percentage of this data is great for making important business decisions, but we also recognize the ugly. That's 75% of dirty data that takes a sophisticated trained algorithm to detect and filter out. Now, back in 2018, I used to say that our data lake goes through 13 different screeners. Today, there are 21 possible screeners that our data can be placed through. And I've named our screeners here. There's a lot of nuances in their screen in how they screen and what they're screening. So you'll see there's multiples for some of these. And actually, we're always adding to this list. So in a couple of months, that number is going to grow to 22 as we're working through some data anomalies that are popping up and creating the filters and training our algorithm to detect and filter out. And hey, in all transparency, we recognize that no data set can be perfectly clean. We're working through new data anomalies, like I said, as they come through, and we're continuing to ensure that our quality of the data is there. So when you're working with your mobile location vendors, be sure to ask, like, what type of screening are you doing? Most vendors are using just one type of screener. They're looking at horizontal accuracy. But as you're going to see in the next few slides, that's not the only thing that you should be looking at. Because we want to end up avoiding some of the things that we see in this slide here. So we do a data evaluation for all of our data sources. And one of the things that we do right offhand is we plot the data on a map to see if it makes sense. And I think for a lot of our researchers out here, this doesn't really make a lot of sense, some of the data points you're seeing. First of all, you have this line, very straight line that's coming out from Europe to Africa. Doesn't really make sense. Is there a new country that had been developed that we're not totally aware of? Because this data vendor is showing that there's a lot of activity in the middle of the Atlantic. And the classic null island. So for those of you who aren't familiar with null island, it's something that the GIS community is very aware of. Null Island is a very popular place. We see a lot of activity there, but it's Null Island because the coordinates are 0, 0. And it's in the middle of the ocean. There's a buoy that sits out there. Obviously, there isn't anybody that's out there swimming and holding on for their dear life, but we have seen a lot of publishers, apps that show this type of coordinates because they want to be in the location data space. They want to show that they have a large amount of data. And so they'll place some field 0, 0 in the coordinate space just so they can be part of the game. And then this is my favorite. And when we were looking at this data, there was lots of jokes that were coming out, and we're like, is that a penguin? Like, what is that strange activity at the bottom? So we didn't go with this data source. Yeah, totally wrote them off because didn't even pass the gut check. But this stuff is out there, and we want everybody to be aware that it takes a lot of cleaning up to get to this place of using good data. So let's talk about why this may be happening. The universe from which mobile location data is collected is very diverse. We collect for Uber Media, we collect from over 150,000 apps. And these are apps where users have opted into location services. And the commonality between these apps is that they're collecting data once a user is opted in. But how they collect data and where they're collecting data and what is collecting data can affect the data collection. So let me dive into that. GPS. So GPS tells your phone or tells the app where the phone is. And so all your smart devices have a GPS chip in there. It's a very small thing that is pretty much trying to triangulate where it is when it's being activated. Uh, how I like to explain how GPS can work or cannot work is with Google Maps or any type of navigation app. We entrust our ability to get to many places through Google Maps or through the GPS that is on our phone, and that Google Maps or Apple Maps or Waze is producing. But as you're driving down the road and you're following the directions as they come up, you might hear your device suddenly say recalculating. And you're wondering, why are you recalculating? Like, I didn't take a wrong turn. I've been following you to the T. But what has happened is that the GPS can't figure out where you are. And so this blue dot that was very precise has expanded, and it's not able to tell where you are. One of my favorite stories around this is actually when I was in India and I was being a tourist there. We had a taxi driver who was taking us to a town he wasn't too familiar with. But if you guys have been there, and a lot of the taxi drivers, they know the area. They don't need a navigation app. But I decided, hey, I'm going to be the hero here, and I'm going to pull out my Google Maps to try to help navigate us to where we need to go. But because the reception wasn't great, I didn't have great service in India, and it's in a very rural area, it wasn't able to figure out where I was, and I almost asked the driver to take a left turn into a lake. So I think I lost all credibility with that taxi driver after that. So what does this mean? So when you're looking at mobile location data, when you're looking at the data that you're getting using this data, there's some things that you should keep in mind. First of all, those little chips on your phone, they've been optimized to save battery. They've been optimized to be as small as possible, but that also comes with some trade-offs. And so commercial grade GPS, there's a margin of error, as with many data collection methods, of 3 to 5 meters or 10 to 15 feet. Just as I mentioned with my India story and navigation story, tall buildings, mountains, that can affect how the phone triangulates or how the GPS is triangulating your location. And so it feeds into this margin of error. It might not be able to figure out where you are, or it might not be accurate as to where you actually are. And then we also have location services turned off or in airplane mode. So what that means is, let's say I'm going to New York. I usually go to New York every year. And I'll turn my phone on to turn off my location services, get into airplane mode once I hit the plane or get on the plane. What happens when I land in New York and turn it off of airplane mode? And what can happen is that it takes some time for the GPS to register where I am again. So it might look like I was able to I was able to be in New York in California to New York within a 1 minute time period, because the phone's still trying to figure out where you are. That data, we've discovered that as a frequent thing that's happening with mobile location data. We try our best to filter out that data as much as possible. So other reasons for inaccuracies, apps, publishers, the developers, and how they built their SDKs can also be the reason why the coordinates or what's being reported with mobile location data is inaccurate. So I have some examples of this, of what we see. Uh, this is a square. We don't move or a rectangle. We don't move like this. There's lines. There's dots all on coordinates right on top of each other. And oddly enough, this was actually in Moscow in the middle of the Kremlin. So to see a box like this and to see data points like this would definitely scratch your head and ask, like, what's going on? And what we discovered here is that there was a publisher who had a few bad apps out there with their SDK. And so we filter out, we put those apps onto a ban list. Now, some of the things that are happening in mobile, within mobile location data, there's these things that are very obvious, but then there are things that are much more subtle. So for example here, what you see here, and if you were to ignore that there were gray dots, but just take a really quick picture of this, it doesn't look too odd. But what we found as we dug into the data is that there were these little lines that were forming a pattern. And so those are the gray dots that you see on the next picture here. And what we actually ended up calling them are worms. We saw these worms that were appearing in our data, and we're like, there's a consistency to these data points that doesn't make sense and doesn't match human behavior. And so we had to figure out, first of all, how to filter it out from our data. And then we were also able to pinpoint it again to those bad apples that we needed to blacklist from our data sources. So apps, publishers, the developers of SDKs, like, why is this happening? It could be that there's fraud being committed. They want to be in the location data game, so they're just trying to get as many points as possible so they can say that they have lots of data points and lots of data. And so they might be committing fraud. There could also be the case where publishers are just clueless about what's going on. They didn't know that it was happening, supposedly. Endless excuses, but that means that we always have to be, mobile location data vendors always have to be on top of the game and catching this stuff during their filtering process. So we're going to take the next section and dive into why mobile location data has become a core source of consumer and tourist insights. But essential to the quality of the data is also the mobile data vendors' privacy compliance. Now, with the nature of marketing and tourism, I know many of you are aware of GDPR and CCPA. These are privacy regulations that have been enacted. As a privacy forward business, we've welcomed these laws as they've provided us with much needed guidelines on how consumer data should be handled, and that includes mobile location data. So we have been independently verified to be in legal compliance with the regulations. And also it's verified that our privacy forward approach is appropriate. So TrustArc and VeriSafe have gone through our privacy practices and given us a thumbs up on what we're doing. But what does that mean in practice? Because the question is always, are you GDPR compliant? Are you CCPA compliant? But how are you compliant is what I would ask as a researcher and an analyst. And what that means as practice is that we have a privacy task force led by our data protection officer, who is always on top, always at the forefront of figuring out what's coming down the pipeline. What are the new laws and regulations that might be coming into play in the next coming years? I had touched base with them before this conversation, and they told me about Virginia's Consumer Protection Act that's very similar to CCPA, California's Protection Act, But that just got passed. So we're looking at that and ensuring that we're in compliance with it, and any nuances that we need to figure out with that law once it gets enacted in the next few years. Um, that also means not only being on top of the new laws and regulations, but also within the organization, the philosophy of how we handle this data. So annually, we've all the Uber Media employees have gone through a privacy compliance training to ensure that we're handling the data right, that we're storing it correctly, to ensure that we are in legal compliance with the regulation. And then lastly, CCPA required that we offer the ability to opt out of our data lake. Now, we could have just localized this effort to just be California, but we understand this is not new stuff. This is going to be things that are coming down the pipeline that's going to be more widely accepted by other states, other countries, other states and other countries. So we offer opt-outs worldwide. You can go to our website and say, I don't want to be part of your data lake. And that's part of being privacy forward. So as such, we formally established how Uber Media handles consumer data, and that's described here. I'm not going to go through the legalese here, but I think what's important is that there is something there. It's how you do it. It's what you're doing with it. And then one other thing is that we do go through and vet through all the use cases that our clients have to ensure that that it is a permitted use of our data. That's why if you ever have me jump on a call, my first question is, what are your use cases? That's what I'm listening for. That I'm also listening. I'm listening for privacy compliance, but I'm also listening about how I can help you, of course. So just as the data filtering process continues to grow, our knowledge and measures to continue to comply with data protection laws will too. We're always one step ahead. So in regards, I know this question is going to come up. I don't know if it's already come up in the chat, but in regards to iOS 14, for example, we've taken 2 major steps to minimize the impact of changes to our partners and clients. And that has included onboarding new data partners who are privacy forward. So in the next coming months, you're going to see a large increase in our data. And what we're looking to do there is to minimize the impact of what iOS 14 might be bringing. We also are exploring other products. We have a new offering called Proxima, and that's a persistent identity solution that uses an algorithm to synthesize all the signals that a device emits. So that essentially, we would not need an IDFA to do some of the analyses that you've been able to do in the tourism industry. We're still scoping that out, but it's definitely, as we're working through how we're responding to things like iOS 14 or any new regulations that come in, we're building our products around that. Privacy is at the top of our mind. So in this last section of my part here, we're going to dive into why and how mobile location data has become such a prime source for understanding visitor and consumer insights. Now, you saw our core metrics. Sample sizes that mobile data can use would typically require thousands of dollars to conduct. While you'll still need an intercept survey to understand sentiment data, our data can't tell you, not yet, technologically, we can't tell you how a person feels or what their experience was like. Mobile location data is great for understanding on a large scale human movement behavior. And so it really allows you to dig into how people are moving through your destination, what they like to, what are they doing, and what are popular attractions for them. Now, it also addresses removing common survey biases. Every data collection method has its biases, right? And with mobile location data, what we're looking to do is to address the ones around demographic representativeness. And this is part of why we're such a large data aggregator, is because we want to achieve population representativeness in our data sets. So Uber made our data collection efforts reflect that. Now, we've conducted bias studies in our key markets, the US, Australia, Canada, and we actually have a New Zealand study that's coming out very soon. And what we found is that there are very strong correlations to income, ethnicity, and education attainment in our device graph. So what does that look like? So we have these white papers that we can share with you at the end of this presentation, but some of the things that we've found, this is for the United States. The blue column represents the census data, and the red column represents what our data device graph looks like. And so you can see that the bars are pretty even, almost even for um, a lot of the attributes around education attainment. We also see that with ethnicity, there is a slight but statistically significant bias with the African American group in our data. We also see that with income, there are some, it skews a little bit more to disadvantaged population. So we do see a slight overrepresentation of minority and disadvantaged populations. And we want you to be aware of that, because awareness of these small differences will allow for you and for our clients to computationally correct for these things. Two other points that I want to leave you with in terms of why use mobile location data. One is it provides data when there's no alternative. So I know that for some destinations, intercept surveys are out of the budget, especially in this time when a lot of budgets have been cut, but there is a increased importance to understanding how the country is re-engaging. We think mobile location data can help with that and as an alternative. And then finally, there's a wide breadth of where you can study. You can't study everywhere. There are, like, China is sort of a black box over there, but we collect data, at least for us, we're collecting data internationally. And so it really gives us a lot of flexibility as to where we can study and how large or how small of an area you want to study. Now, before I toss it over to Evan, I do want to talk about some limitations of mobile data, because as I mentioned, there are some great things about it. There are things that you need to keep in mind, and there are limitations as well. So I always say mobile data is a sample. And I think a lot of you understand that. We have some statisticians out there who get this. It's not 100% of the visitors, and it shouldn't be treated such. And some of the reasons around that is mobile data, first of all, is very intermittent. So we're not capturing every device that goes into a location, or every move a device makes. For example, me and Evan could have gone shopping together and found that what our data is showing is not the same, because what I'm showing, the apps on my phone might be collecting data every 5 minutes, but Evan's apps are collecting data every hour. So maybe we went to every store in the mall, but you're not going to have seen Evan in pretty much every store in the mall. You might miss some of the ones that I glazed over as well. And then finally, the raw data for mobile location data does not allow for visitation counts. So I know there's a lot of people out there who want to use mobile location data to understand the number of visitors that are going to the location and whether that's increased or decreased. And it can be done, but not just with the raw data. And there's a lot of data science work that needs to be done before that can happen. This has been a years-long project for us. We have that we've been working on, and that our data science team has been heads down on. But with the raw data itself, we always say, like, look at how your share of visitors have changed. Don't focus on with this data as to how that pie or how that volume has changed. All right, so I'm going to toss it over to Evan now to talk about the data set possibilities with mobile location data. So let me actually stop sharing here and hand this over to Evan.
Awesome. Thanks so much, Evelina. I'll share my screen. Desktop too. Awesome. Now we get to talk about one of my favorite topics, which is data sets. Data sets specifically aimed at answering these three questions. So think of the next 10 minutes, if you will, like a brainstorming session. I'm going to walk you through different data sets used to answer these questions with the hopes that you can just conceptualize how what data sets look like and how you might be able to use them, whether it's to answer questions about an event or just ongoing monthly updates, how things are changing. And we're going to start with a little story about my favorite event in the world, the Boston Marathon. I am biased because I'm from Boston, but I enjoy going into every year and really hope it's on later this year. But right now you're looking at what a geofence is. We call it a polygon, but essentially it's a hand-drawn area on a map. And this just tells us where to get data from. As Evelina referenced, we already have all of this data on a global level. This geofencing just tells us where to get data from. And this is a pretty simple geofence. This is just a box I drew, but this is where I watch the Boston Marathon from. It's kind of the finish line area. There's also bars and restaurants there. I call it the finish zone on here, but I draw a geofence area. And now I'm going to show you how the data starts. This isn't necessarily how the data comes to us, but this is the rawest form that we provide other partners. And it looks like this. This is just a screenshot of Excel that I'm showing you. We're looking at a subset of Boston, that finish line area. So I'm going to walk you through this really quick. Column B right there, those are different devices. And you see it's the same device. There's 3 different devices there. And essentially what this data set is doing is it's telling us where these devices are and when were they seen in those locations. So you'll see there's a few columns here. The first is C and D. Those are the latitude and longitude of essentially where a phone is, where a device is. And you can see in column B that this phone is giving off a bunch of different locations. They're pretty close together. Of course, as this person's walking around or maybe just standing still watching the Boston Marathon, but associated with each ping is a timestamp. F and D are basically my favorite timestamps to look at here. So I can see essentially, this is just a subset of a much, much large data set. I can essentially see where this phone was and when it was there. Super simple, super straightforward. Again, this is just the finish line. If I take this data set and visualize it, it looks like this. Just pings on a map. Cool, useful? I don't really know, but like neat. You can see how the data gets visualized right there. And that's kind of how it starts. It starts with people giving off their ping and us being able to provide this in a contextual way to partners that can visualize and make use of this. But if we expand this out to essentially all of Boston, and we want to look at the Boston Marathon and phones giving off their little pings as they travel around, we can visualize that nicely. And this is all of Boston. This is actually the day before the Boston Marathon. They shut down Boylston Street here and Newbury Street, maybe walking only streets. Red Sox Fenway Park Stadium here on the left swells up with people going to early Red Sox games. It's a Sunday, I believe, afternoon game. Not a lot of people along Comm Ave and towards the beginning of the not the beginning of the finish, I guess you could say. But here, as we go into the evening hours, you can see there are still some densities of devices. Those are mainly at hotels. I can see actually, if you know Boston, those are pretty vividly some hotels, some residential streets. These are the early hours, people still at hotels, people congregating essentially now in the Back Bay area, coming in to watch the match. Looks like we're about 10 a.m. here. Racers start crossing around 11:30 noon, at least the wheelchairs first. But you can see there's also a Red Sox game that starts around 11:30 a.m. on this Monday. You can see that swells up, and here's the peak time. You see the race line totally full of spectators there. You see people then will start to disperse as it gets into the evening. This is essentially how the data all starts. But then, of course, one has questions about this, like, well, what percentage of these people are tourists versus locals? What hotels are these people staying at? What's their length of stay in Boston if they attended the event? Are they just there for a day trip? Are they for 5 days? Are they visiting any other attractions in the area? So we can use other data inferences to answer those questions after we just look at quote unquote pings on a map. And the first thing we always want to ask are, well, where are these people from? It's a super simple question, and we have a lot of fun answering it. The way we answer this question is not based on a SIM card, not based on an area code. It's based on real device data. So think about your phone. Your phone goes back to the same location almost every evening over the past 3 months. That's your phone's common evening location. On the flip side, your phone has a common daytime location, basically where it works. Most of our common daytime locations are our common evening locations because of COVID, for better, for worse. But when you think about a tourist coming in for the Boston Marathon, we want to make sure their common evening location is at least 50 miles away from Boston, but they also don't work in Boston. Because you can bet there's a lot of great offices all around the Boston Marathon finish where employees will come in just to watch the marathon or come to a place where their office is, even if they live far away. So we want to bifurcate who a tourist is. I guess that's more trifurcate, if that's a word, but a tourist, a commuter, and a local from that to understand and parse all those out. So we understand what a common evening location and daytime locations are. Let's look at them in a data set. I'm going to walk you through this a bit more, but essentially what we see here is a simple data set that tells us where are people from who are seen in Boston during the Boston Marathon. Again, column A right there, you can see that that's the polygon. It's just greater, or I guess all of Back Bay, Boston is what I drew it to do this. But you'll see column B right there. Those are all hashed and anonymous device IDs. And we'll walk through what that is essentially in another slide. But each row is a different device ID. Each row is a different person. And the question we're answering here is, what is the common evening location of that device? C and D is the latitude and longitude of that common evening location. So it's super, super specific. Great if you're using mapping software. I'm using Excel right now, so not as useful for me, but we add context to that. So E is the country that device is from, mostly American. We see someone from Japan, Ethiopia, Great Britain, UK. F is the census block group that device is from. G is the city that device is from. H is the DMA or metro area, depending on what country we're looking at. I is the county that device is from. J is the state or province. And K is the zip code or postal code. Excel takes off the first zero with the postcode numbers. So with something like this, perhaps for people from Massachusetts, we might look at what postcode they're from or even what census block group they're from. Out of state, maybe what state or DMA they're from. Maybe Canadians, we also want to look at what city Canadians are from, probably majority from Toronto, but who knows, we should look at that. Maybe from Europe, we're just looking at what country they're from. So there's a few ways you can summarize this data. But if I just summarize it by Americans and what state they're from, again, I just did this in Excel, nothing too slick, if you will. I did a pivot table, it took me 2 seconds to understand, okay, well, who's at my finish line area there in Boston, watching the Boston Marathon finish with me. Here are the top 10 states of Americans. That's a really quick walkthrough on kind of how that data works. But I'm going to share my screen actually and just open up Excel and kind of just show you a bit more here. So let me bring up this Boston report here. Let me know if you can't see my screen at all, but essentially this is exactly what I just showed you before. We have these device IDs, all of them are unique, visiting Boston, and we're looking at where they came from here. Very cool. This is their common evening location, right? 2 people from Toronto. I did think Toronto would be the different places in Toronto, but did think Toronto would be popular. But over here, as I scroll over to the right, we can also see the common daytime location as well, the CDL. And so I might just care about that from people, of course, who are in Boston. I want to know, again, are people commuting in to watch the marathon? Do they work there? Are they residents already, or are they actually truly tourists? So using a data set like this, just simply understand and answer the question, where are people coming from? But the next data set I'm going to show you, which is my favorite data set in the world, tells us about length of stay, because that's a crucial element. So do these people just come in for the day to watch the race, or do they actually spend a few days? In fact, Boston, many of the hotels in Back Bay, it's a minimum 4-night stay there. But so this is a data set that tells. Let me walk you through this, because again, if there's one thing you can take away from my section of this presentation, it's literally this spreadsheet right here, as I love it. Column A, again, those are all the same. This is sort of repeating itself. All of those are device IDs, and they're visiting column B, which is Boston. And the question we're answering here again is, where are these people from? Super simple question, but again, important. But what you'll notice here is that this device repeats itself 5 times. And again, this is for the whole year. So this isn't just looking for Boston. I'll show you what I mean here. So this device is visiting 5 times to the city of Boston. They're from Knoxville, Tennessee. And this is our origin marker with length of stay data set. But as I sort of scroll over here, now I can see, when did that trip begin? When did that trip end? What the length of stay of that trip is in seconds, but you can round up, and whether that trip was a day trip or overnight. So I can see this person came 5 times in August. 4 of the trips were overnight, 1 was a day trip. 4 of the overnight trips were, or 3 of the overnight trips were one night, and then 1 of the overnight trips was 2 nights over the weekend, Friday, Sunday. So it's neat. I can just essentially see this person made 5 trips, and I can kind of summarize the data how I want to. You can see this person, for example, right here made 3 trips. They're from Birmingham, Alabama, and their trips were in August and September. They came at the end of September. All 3 were overnight. So this just tells us essentially about origin markets and length of stay. And of course, if this was looking at the Boston Marathon, I can isolate just the days before and after the Boston Marathon, and then I can see what people's lengths of stay were. So it's not just where did they come from, but also did they stay a long time in Boston itself. Now, a lot of people, so we're asking sort of the where and the length of stay. A lot of people ask us how you get demographics from this. And let me walk you through that really quick to answer the who question. So the data is all anonymous. We don't actually know who is showing up, but we know where they come from. And more importantly, we know the census block groups that they come from. So the best way to do demographics, which might not be the best way in the world, honestly, but it is a great tool to get demographics from an anonymous source of data, is we take these census block groups right here, and we look at the demographic profile of those census block groups. So if there's 50,000 devices, let's say we picked up at that finish line area at the Boston Marathon, we can look at the demographics of all the census block groups that they come from, and then paint a picture of the demographics of those census block groups, rolling it up. And it kind of, if we take all these census block groups, all these census IDs of these people who are coming, we can then essentially summarize the data. This is directly from the Census Bureau by age, household value, household income, education, ethnicity. And we can do this not just for Americans, but many other countries as well from publicly available data. And so this helps us paint a picture of who is coming, even though the data is all anonymous. And this is about the census block groups that they come from. So it's a really great way to kind of take all that data and put it together. And then lastly, I kind of want to show you the what category as well. So I'm going to show you really quick. This is a same file, the origin marker with length of stay data set. This is for Highway 50 in Nevada. It's a huge highway. A lot of people do essentially road tripping there, spend many nights. And so we're looking essentially what's the length of stay of people just along Highway 50. And again, we can look at, this is just a subset of the data. We can see who's overnighting, who's day tripping, what their length of stay was from, what DMAs they're coming from. So it's pretty neat to be able to see that. But now I want to know, did they visit attractions along Highway 50? What did they actually do? Well, we can pull up another data set here that tells me essentially what those people did. So for example, this is a very simple data set, but this shows me what devices or which devices visited which points of interest and when they visited. So essentially I can go back to that same data set as before, and I can look at, I just want to look at overnighting out of state devices. I can find them in this data set. And once I've isolated the overnight out of state devices, I can then look at on this data set and see which of those devices here are out of state and overnight, and what did they do? Pretty sort of simple way to answer that question, where people are coming from, what they're doing. But then you can really cut up the data and look at length of stays, certain holiday weekends, certain summer months, and really dig into, are people's length of stay increasing, decreasing? Do people have shorter length of stays, visit more things? Are people from in-state or out-of-state or overseas likely to do what, and in what order, and build out itineraries? So this is kind of how that data starts. And we have a lot of fun, honestly, digging into it. So that's the really quick view from that. And we love providing sample data sets too, if you ever want to see those. But taking those data sets is great. I get excited by them, but I know a lot of people I work with or present to don't. They like to see visualizations of the data, and I don't blame them. Excel can only be so exciting, if you will. So to visualize and kind of make this data look quote unquote cooler and kind of help tell a story more, here's some really great softwares you can use. Some of the vendor partners out there that leverage our data use these softwares. Tableau public is free. There are free tools out there. This isn't necessarily a gold standard, but it's a really great list of softwares that you can use our data in a variety of different capacities there. And for example, Tableau Public, which is free, looks a little like this. And some of you are probably very familiar with this. This is the US Travel Association's Ski Mountain tracker, if you will. This is from last year, but it answers that sort of same question: where are people coming from and when are they seen at these ski mountains and who are they? I can choose different ski mountains. I can look at different date ranges here, and all the data automatically updates at the bottom. So it's a really neat way to use our data and visualize it to answer questions as opposed to just doing screenshots of Excel. This is also a national parks one that you may have seen over the summer that we do with USDA. But sometimes, of course, we look at just dispersal. And going back to that beginning, that very first slide where I showed you just pings from devices, sometimes it's good to understand dispersal. Where are people going? Where are they not going? And sometimes it's nice just to see dots on a map, because then we can understand, are people doing more or less things? I'm from Boston, for example. I've been going into the Back Bay for the past 6 months. I haven't been doing anything else in Boston, mainly because of the weather, but also COVID. Plus, I can't really convince friends to do things with me due to both weather and COVID. But I'm hopeful now. Spring's coming out. COVID feels like it's sort of going away. I'm excited to venture out to more of Boston than just the Back Bay. And you will see me as that disperses. And so we can isolate different visitor segments and kind of see how they disperse more, which is a good use of the data. So we kind of end this section with, we work with a lot of vendors, I should say, out there. Probably about 75% of our work in tourism is through other vendors, and we love our vendor partners. There's over more than a dozen out there that we work with on a weekly basis at the least. So we encourage you to ask your vendor if they work with Uber Media data, and you can access these data sets or ask questions and understand kind of the quality that we pride ourselves on with this data. So that ends my section there. I'm going to pass it back over to Evelina to wrap us up there.
Thank you, Evan. So let me go ahead and share again. Evan, we look good here? Awesome.
Looking
so,
good.
Evan's gone through some data sets, and what I wanted to end with is how we would do an analysis here over at Uber Media with some of the data sets that you saw today. The data sets that Evan showed, that's been last 2 years, almost 3 years of work where we've just been working with tourism destinations to figure out what questions they want to get answered, like what are the best data sets for that. It's all possible with mobile location data mobile location data. So understanding that possibility, like keep asking what else can we do? Like, can you do this? Can you do that? We love hearing that feedback. So in this scenario here, what I did is we wanted to look at Legoland and understand, okay, what are the proportions of tourists versus locals? We wanted to understand a breakdown of the tourists and the top source markets. And we looked at a January to June 2019 timeframe. So you saw some of the data sets, but I'm going to tell you how you use the data sets here. So the primary data sets that we used for this analysis were our common evening and daytime location report. And then we also have one that looks at whether a device is a resident or worker within that location. So we have a lot of clients who say, I don't want to count the workers that are in the data. That's going to end up skewing the data. So we want to first, here's our methodology. And the first thing that we do there is we identify visitors versus employees. So we'll take that resident worker report. We'll look at whether they are a resident or a worker, so true or false. And if it's true, then we'll go to the CEL or common evening, common daytime data set, and we'll remove them from the data set so they're not included in the analysis. So once you've done that cleanup, and we provide a lot of data because each destination has a different definition of how they want to do things. So we're on this our philosophy is we want to give you everything, and you can filter out what you don't need. So from there, once you have that part of the data set removed of employees, what you can start doing is creating segments. So you have everybody has their different visitor segments and how they've defined their visitor segments. And here we wanted to look at locals. So they live within 50 miles of the study location. Also, they're not a worker in the study location. And then we also want to look at tourists, and there's a breakdown of tourists here. So we are breaking it down or defining it by states, as well as by whether they live outside of the US. So they would be international clients. And our data sets are already geographically contextualized, so you can readily do this type of filtering. And we also provide in the data set a distance of where the common evening location is from the study location that you're looking at. So with these three parts of the data set, we're able to start doing this type, we're able to start doing the segmentation piece. And so once you've done the cleaning up, once you've done the segmentation, you can start looking at your results. So what we saw with Legoland is we broke down that tourists and our locals. We saw that 71% of almost 72% of the visitors to Legoland fell in the tourist piece of the pie, and about 30% fell within the local piece of the pie. We also broke down the tourists themselves and what that looked like. We saw about 50% were in state, so they all live in California. And then we saw a breakdown of actually long haul being the second piece of that pie at almost a quarter, and short haul at 20 and 6% with international. We can further break this down because you saw that contextualization, the geographic contextualization that we did. Well, that also allows you to break it down by origin markets. So you have here with the metro areas, you can break down what are the top metro areas that the location is drawing from. So not surprisingly, Los Angeles is at the top of the list, but also San Diego, followed by the longer haul or the farther metro areas like San Francisco. You can also break this down internationally and understand how that share or how the internationally, how much more or less you're getting visitors from each of our international markets. So Mexico was at the top of this list, followed by Canada. So this is just looking at origin markets. We can also look at in other studies, we can also look at people who go to Legoland. What other attractions are they going in San Diego? We could also, as Evan mentioned, look at length of stay of how long they stayed within Legoland and how long they also stayed within the larger part of San Diego. So all possibilities of this data, but I wanted to do a really quick run through of what you can do with just 2 data sets and the insights that you can glean from that. So that was a really quick run through of mobile location data and what you can do with it. I am sure as you dig into the data, we anticipate there's a lot more questions, but also we have addressed a lot of the questions that have the frequently asked questions and put together white papers around that, as well as an FAQ. So if you like more information on what you've seen today in terms of like, what does your demographic study look like? Or can I see the other countries that you've looked at? Please email Evan here at ubermedia.com for the white papers.
These white papers, by the way, we have a lot more than just this. We just thought in the flow of what we presented today, these might be great follow-up material with the spirit of this is an educational session, being transparent with all this data. Someone asked just a sort of follow-up question about common evening locations. You know, it's just interesting too, when we do a lot of work outside of America, people ask so many questions about SIM cards as well. Not as popular of a question inside America, but a lot of this documentation sort of covers how we account for all of that. We go into pretty good detail, both domestically and internationally. We don't get your email addresses, so that's why if you want these, reach out to us and we can send you these. And then of course, you have other questions, feel free to share. Our product at the end of the day is data, and there's so much you can do with that. There's so many questions you can answer with that. And honestly, we live and breathe answering those questions, or we work with more importantly our vendor partners to answer those questions for their clients. So we really enjoy this. So I hope you found the last 55 minutes pretty educational. Yes, the presentation will be shared after this. I believe everyone gets the presentation. If not, email me either way, and I'll make sure you get the presentation. And it looks like we answered essentially everyone's questions throughout this. One there about car drive tourist GPS available. I'm not sure I exactly understand the question. So you want to rephrase it, you can, but essentially phones, anything with a sort of GPS really gives off its location when it comes to mobile devices, mobile phones. So we'll kind of leave it at that. Appreciate everyone joining. Hope you found it educational. Hope you're a little bit more of an expert at mobile location data. And honestly, have a great rest of your Wednesday and a good start to your spring really soon.
Thanks, everybody.
Thanks, everyone.
Thank you, everyone, and we will hope to see you at our next webinar. Have a great day.